capacitors in DC circuits. It's the general topic of what I want to do tonight. Yep. Okay. Capacitor is two conducting plates with connection leads. Yeah. And then between that insulating material, that's called the dielectric. Examples are air, ceramic, mica, etc. Yeah. And then you get electrolytic dielectrics, which are an electrolyte. Okay, but essentially it's an insulating material. Okay, and we'll talk in a minute about what the level of capacitance depends upon. Yeah, but quite often in bigger capacitors the conductance sheets are foil, long foil with insulating paper between, so they can be rolled up like a roly-poly and give you more surface area. Yeah. Level of capacitance depends on one, the area of the plates, larger area equals high capacitance. Yep. Number two, distance between plates. Which inherently means thickness of dielectric. Okay. Less distance, more capacitance. Okay, and thirdly, it's inherent in material used for dielectric. I'm not an expert in capacitors and the different types, but certainly of the examples I put, air is the worst dielectric. you're talking about what its dielectric strength is and its ability to withstand charge leaking through it. Because although you say that's an insulator, there isn't a perfect insulator out there. Okay, the only where air is really used is in variable capacitors. What they have is, if you look in the back of real old style radios, the tuning circuit's got a variable capacitor in it, and that's a set of fixed plates with a set of fins that move between them. So what you're varying is the area between the area of plates that are opposite each other. But because your air dielectric, so they're inherently quite low values of capacitance, but used in a tuning circuit to tune into a particular station. All right. The other materials that have a much higher dielectric strength and therefore can inherently hold more charge. Okay. Capacitance. Symbol C. Measured in farads. F. Capital F. Yeah. 1 farad is very big. Therefore, we use microfarads, UF, and that's 10 to the minus 6 farads. 1 microfarad is, yeah, nanofarads, lowercase nf times 10 to the minus 9 farads, and pico commonly referred to in the electronics industry as puffs of capacitance. PF times 10 to the minus 12 farads. Make that look like more like a C. Look a pico, pico. Mental note: Michael must learn to write much neater on the board. Alright, so yeah, I think you probably remember that from before, yeah? Okay. So, what do capacitors do? Capacitors store charge. If we connect a capacitor through a switch to a source that will provide an electric current, like so. So when we close the switch, a current flows, I. Okay. Now, although we use the convention that conventional current flows from the positive terminal of the battery round the circuit to the negative terminal of a battery, in actual fact the flow is electrons in the opposite direction. Yeah. Okay. What actually happens is, over a period of time, the subject to that period of time is next week's lesson, yeah, we'll end up with negative electrons, and I'm going to draw 4 of them on that plate. The equivalent number of positive atoms on that plate, and that's because electrons have left these atoms and moved around and gone onto that plate, and they're held there by the force of attraction between positive and negative charges. Yeah, but there'll always be the same number of atoms with electrons missing as there are extra electrons on the other plate. Yeah, so eventually, if this is a 5-volt battery, you'll see 5 volts across there. Alright, and when we disconnect, turn it off, the 5 volts will stay because those charges are held by the forces of attraction between positive and negative charges. Yeah. Let's put a note on there about that. So, and we remain charged to 5 volts due to the attraction between the plus and minus charges across the dielectric. Yeah? Now, if the capacitor was perfect, no leakage, it'd remain charged 10 volts indefinitely unless we connected a conductor across the capacitor so that it discharged. So if it was perfect, we could have that capacitor sit there charged indefinitely, and we'd measure 5 volts across there if we used a perfect meter that didn't draw any current. Yeah. Okay, if I then do that, technically through some kind of resistor, otherwise we'd get a large technical current flow, then a current's going to flow so that it equalises the two charges again, and we'll have no volts, so it'll discharge through that resistor. Again, the charge-discharge cycle is the topic of next week in detail. Yeah? So, a good quality capacitor will hold a charge for a considerable amount of time after disconnection. Yeah? Yeah, it depends on the dielectric material, how much charge they can hold in the first place, whether what the leakage is, okay, but a good quality one can remain charged for quite some considerable amount of time.
Hours?
Yes. Not sure. Yep. Not sure about days.
That's still a long time to hold hours, so hold it.
Right, holding of charge. In real capacitors, can be for a long time. On a 400 volt nominal AC system, capacitor could be charged to approximately 600 volts safety issue, because a big capacitor can hold a lot of charge for a considerable amount of time, and I've had a shock off them in my time. Yep. Always worthwhile having a little lead, getting a little lead with a resistance in it, and just clipping it across, discharging. Okay. Big motor inverters quite often got, well, they've got a lot of capacitance in for the rectification. They have a little LED on them that you're supposed to wait until it goes out before you take the cover off. Yeah, it's worthwhile just making sure capacitors are discharged, and that's not necessarily a good idea to do it by connecting your spanner across the terminals, because they can hold quite a lot of charge. And I've seen a piece of wire wool dropped onto a biggish capacitor that's charged up, and that just disappear, and you get a big kind of flash. Alright?
So they don't put their tongue on it?
No. No. Tongue? Did I tell you about people dying from chest and 9 volt batteries with a tongue?
You said about it last week.
That's something I've never done. I wouldn't do that.
Just would.
No. Well, I wouldn't anyway.
Well, you took the test and stick it out.
Yeah. Okay, so we got a relationship between charge, right, capacitance, C is equal to Q divided by V. So there's a relationship between the charge, the level of capacitance, and the voltage. Q is the charge, measured in coulombs, symbol C. Yeah. Capacitance, C is the capacitance, measured in farads, as we already said, and V is the voltage, measured in volts. So a charge stored is Q divided by V. Yep. Also, we can get to the charge from another direction. So, yeah, a capacitor is charged